Howdy folks, welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're finally going to finish integrations, because I don't know about you, but I'm tired of talking about integrations. So, where we left off last week, we got through the process of setting up the GitHub integration to actually store both in our database as well as on GitHub. So if you don't remember, let's go ahead and cruise here. We're going to go to the settings page, integrations, and we had worked our way up to getting a connection to GitHub. But last week what we did is we talked through the process of actually saving this integration, and then in our code we talked through actually creating webhooks on GitHub. So webhooks being URLs that GitHub is going to send events to when something happens in relation to a repository. And that repository is chosen by our user, setting in this dropdown saying, hey, I want you to send me webhooks for events that belong to this repo. So that's where we're at now. We've got our webhooks. So if I go over to our test GitHub webhooks repo that I set up, we can see we've got our development webhook URL here. So again, I use a service called ngrok to do all of my development environment webhook testing. That's a terrible way to say that. All of my, I don't really know how you say that. That's how I test webhooks. I use ngrok. Basically, it allows you to get a tunnel from the interwebs into your local host or into your computer, and you can point it at your local host server. Goodness, that didn't come out, but hopefully that makes sense. So where we're at now is we have a functioning webhook where we can send things from GitHub when things happen in relation to our repo. Now, in command, there's two things that we're trying to watch for. So we're trying to watch for mentions of card numbers inside of commits in our Git repositories, and we're also looking for close commits. So if you've never done this before, a close commit looks something like, if I say close is number 19 inside of a commit message, we want that to trigger some behavior in our application. So what I've gone ahead and done here is I've set up our GitHub integration for test GitHub webhooks, and I've toggled both of these options to true. So what we're going to do is actually test this out. We're going to see, can we get a mention of a card number to show up in a cards activity, and we're also going to try and close a card purely via commit messages. So literally no button pushing or anything like that on command. We're going to do it solely through the GitHub webhook event coming through. So where we want to start is, let's do a test run here. So we're going to go back to our cards list, and I was playing with this one earlier, so just to give you an idea of what this looks like, this is me closing the card, and then I kind of opened it and closed it and opened it again. But this is what we're after. So this is when we close a card via commit message on GitHub. So if I go ahead and pop this open, you can see that this points us to some change in our code, and the commit message testing closes number 49. That's what actually triggers the close event inside of our repo, or inside of our card via our repo. So that's what we're after. So what we're going to do is pick out another card here, and let's just do 47. Is this clean? Yeah, okay. So what I'm going to do is show you what this looks like first, and then we're going to kind of go backwards and look at the code so we can understand this. So what we're going to do is jump to this screen. I've got like 20 different screens to demonstrate this. It's pretty gnarly. Okay, so we're just going to say this is a little change, and then we're going to go back to our terminal. There it is. All right, so now this is where this becomes important. So notice it's not the code that I'm writing where we're watching, it's the commit message. So what I'm going to write right here is what's going to dictate what happens. So what we're going to say is work in progress. What number did I have? 47. There's work in progress, figuring out number 47. So what we hope to happen is we're going to commit that, and then I'm going to push this to master. And we want to watch this tab up here. So this is my ngrok tab, which again is my tunnel into my computer. So after a few seconds, we should get a message from GitHub, and we do. So we can see that, okay, at least that part's working. GitHub sent us a message like we asked. We don't have any errors in our terminal, which is good. So now if we refresh this card, there we go. So keep in mind, I didn't tell it to close anything. All I did was mention the number. So this is good if your team is working on GitHub, but you're tracking your work inside of something like Command. You'll be able to see when somebody's talking about a specific card. So I don't know, if you're a manager type or if you're just a developer who's trying to oversee some work, you're going to want to know, like, oh, okay, somebody's actually working on this. And then we can click on that link and we can see this is a little change. Pretty neat. So the question is, how the heck did that happen? Because this is one of those things that's simple but not easy. As we've kind of learned, you would think connecting to GitHub and setting some credentials and stuff like that, it should be pretty easy, but it involves quite a bit. And not unlike everything we've seen so far, getting to this point where we actually have an event on a card, surprisingly complex. So what we're going to do is jump over to our code, and this is what we worked on last time. So this is creating our hook. So we're going to go ahead and close that out. And what I want to start with is this file. So this is where we define a server-side route for actually ingesting webhooks inside of our application. So the way this is built is not service-specific, meaning there's potentially going to be tons of webhooks being sent to command. And so we want to design it so that it's generic enough that it can handle any webhook for any service. And then putting the burden on us as developers to say, okay, how do we want to handle that specific service, that specific service's webhooks. So what I've got here is a server-side route being defined. Now, I'm using a package that I've personally used for a while for doing server-side routes called Meteor Hacks Picker, and this is a Meteor package. I don't use those too often anymore, but I found that this one solves this problem really quickly and easily and does what it needs to. Technically, if you're inside of a Meteor app, you can connect to the existing web app instance, but it's a little harder getting at the request body and the params and all that, and it's just, it's a fuss, so I've just kind of stuck with this, and it's one of those things like, it works, it works. So what I'm doing is I'm saying, okay, when any request comes in, we want to parse the body as JSON data, but then the important part is right here. So I'm saying, here's how we're going to handle a request to this URL, or I should say one of these URLs. So we've got /webhooks/ service. So just like we see on the client side of our application when we're defining routes with something like React Router or another client-side routing tool, whenever we see colon and then a word, what we're getting there is a route parameter. So that's like a variable inside of your URL. So in this case, we're saying this could be /webhooks/Stripe, this could be /webhooks/GitHub. It doesn't really matter. The point is that we have one endpoint that we give to all services. The only thing that we change is their name on the end of it so we can identify like, who's sending us this, where is this coming from. So there's some trickery going on here. So something that I've done for the very first time is added a queue when I get a webhook. So in the past, what I've done is I've just handled a webhook as it's come in, and I basically said like it either worked or it didn't, and that was it. But what I realized was there's 101 different things that can go wrong when it comes to something like webhooks. And the reason why is we're taking this foreign data, pulling it into our application, or actually it's being pushed into our application. We don't even get to decide that it's going to be sent to us. And then we have to be certain that our code is going to handle it properly. And if all things are going well, then yeah, it should just work. But there are going to be situations and there's going to be weird little gotchas, like network activity, like the network's going to go down, or wherever we're hosting our application, they're going to have a hiccup and it's going to just miss a request or something like that. And so what is wise to do is to build this as though it's fault tolerant, meaning whenever we get a webhook coming in, we want to log that webhook into a queue. So a queue is going to allow us to do a few things. One, it's going to make sure that to the best of our abilities, we're going to actually handle that event or that webhook. And then it's also going to make sure that we don't overload our server. So the thing to remember is when we're building with pup. So again, pup is the boilerplate that I use with mentees at Clever Beagle, and it's built on Meteor, which is built on Node.js. So Node.js is single-threaded, meaning any work that you do that's blocking is going to literally block the server for everybody, which we don't want to do. So where Node is actually quite performant is in asynchronous behavior. So basically, we can push in an event and handle the event so typically you'll see this in a callback pattern. So we'll say, do this thing, but then tell us what happens via the callback function. So either an error or some response came back. So we can take advantage of that behavior in a pattern like this. So what I'm doing is I'm using a package called bull. And bull is the fastest, most reliable Redis-based queue for Node. And you're probably like, what the hell does that mean? So what that means is this is helping us to build a queue using the Redis database. So Redis is a different type of database, just like we have MongoDB as a database, or we have PostgreSQL or MySQL. Those are all different types of databases. And what Redis is doing is instead of writing stuff to a disk, meaning a hard drive or a hard disk, what it's doing is it's just keeping stuff in memory. And so through that process, and don't ask me because I'm not totally well versed in this, I just understand it enough to apply it. What Redis is allowing us to do is to very quickly hold on to data, process it, and then get rid of it. So Redis is like a traditional database in that it can persist data to the hard disk and all that stuff. But traditionally what it's used for is just really short-term data store. So that's exactly what we're doing here. So this bull package allows us to develop a queue with it. So quite literally, if you think about you're at the grocery store and you go up to one of the registers and there's 10 people in front of you, that's the queue. So just like that, when it comes to our webhooks, for every person going up to the cash register, that's a webhook coming in. And so eventually the person working the cash register, they're not going to be able to just instantly handle all of those transactions. They're going to have to wait to go through the process so everybody can scan their items and all that stuff. So in the exact same way, our code is behaving that way. So what you want to think about it as, we get a webhook coming in, and us handling it is like swiping items at the grocery store and handling payment and all of that stuff. Arguably significantly faster, but because we're dealing with potentially high streams of traffic coming into our application, the same principle applies. So what Bull is helping me to do is to create our queue, and it's deviously simple. So what it's doing is it's saying, okay, we're going to create a new queue. You can see here I'm defining the webhooks queue, and I'm pointing that to my Redis configuration. So we're not going to look at that, but if you look in here, the documentation for this is pretty friggin' solid. Redis config, I just saw it. Redis config. Yeah, there you go. So this is the structure that you're after. Personally, what I'm doing to actually work on this is I've downloaded and installed Redis via Homebrew. So I did brew install Redis to get it installed on my machine, and then apparently my voice is cutting out today. To run it, I'm using this client-side app called DB Engine. This is just me being lazy. Technically, I could run it meaning I could run Redis via my terminal. But in this case, I just want to be lazy. So I just say stop or start Redis, and that does the trick. So this I've got running in the background so that we have access to that. Generally speaking, setting up Redis. This is the first time that I've honestly used it aside from playing with it. Quite easy. It's not something that's going to take you or shouldn't take you too much effort. If it does, feel free to leave me a comment here on the video, and I'd be happy to try and walk you through whatever I can. So that's what we're doing there. So we've got our queue being defined, and we're connecting to that Redis instance, and then we get to work. So there's only really two things that I'm doing here. So when a request comes into this URL, so again, when GitHub sends us a webhook, what I'm doing is I'm saying, okay, in that queue, I want to add a job to be done. So that's the generalized name that we're going to use here. This is a job. So even though we're looking at it as, oh, this is webhook data, the queue doesn't know that. So we're just saying, like, okay, we're going to add a new job or a new webhook to process to this queue. And so it's very simple. So we say webhooks queue.add, and then we tell ourselves, well, what is the data that we're keeping track of? So again, we're dealing with a temporary database here, an in-memory database. So we're still persisting data. The only difference is that we don't intend to keep it around indefinitely. So what we're doing is we're saying, okay, we're going to insert an object, and it's going to have the name of the service. So in this case, this would be something like GitHub. and then we pass all of the params. So again, we're trying to generalize this behavior to work with any service. So again, this has nothing to do with GitHub. This is just us saying, okay, catch that webhook, whoever it's from, and then we'll handle it in some way later. So the handle it part is us designating this service. So we're saying, okay, the service is GitHub. So that tells us later, and we can see down here, if job data service equals GitHub handle GitHub webhook, that's going to tell us which path to take that webhook down. So back up here, we're saying, okay, here's our service, here are the params from the request, here are the headers, and here's the body from the request. So literally all of the data that we would need to actually process this webhook or handle this webhook. And then after that, we've got a configuration object. And so what I've decided is that for every webhook that comes in, I'm going to give it up to 5 attempts to succeed. And so this is the beautiful part about Bull, is that it's doing this work for me. I'm not having to think about it. I'm just saying, hand it some data, and then, as we'll see in a few minutes here, process that data or try to process that data. And if it fails for some reason or you get an error, just put it back in the queue and try it again. So the try again process is every 60 seconds, so every minute, if an attempt fails the first time, it's going to go back. And then if it fails again, it's going to try again. So it's going to do that up to 5 iterations, and then it's just going to stop. And you can see here I've got remove on complete true. So what I'm saying is, as soon as that job is completed, gone. It's out of Redis, meaning it's not being kept, it's completely gone. And so this is where the power of the queue really comes in, is that we can hold it in our database long enough to take care of it or process it, but then we don't need it, so just get rid of it. And that's the idea here. So again, very simple. So we add the webhook that we get into our queue, and then we just tell whoever the sender is, so in this case GitHub, we say 200 for success, and we say, hey, all right, webhook received, don't worry about it, we'll take care of it from here. And so the take care of it from here part is down here. So you can see we've got webhooks queue.process, and then what I'm doing is I have a function called webhooks queue process taking in the job. So this is happening in real time, meaning as soon as something is added, the queue is going to try to process it. So if the queue is currently empty and a job comes in, it's basically going to be run instantaneously. If 10,000 webhooks come in at the same time, then whatever that last one is, it's going to be appended to the back of the list, and then this queue is going to get to it when it gets to it. So again, you want to think about like the grocery store clerk swiping groceries. They'll get to the end of the line when they get to the end of the line. Same exact idea here. And the speed and efficiency of that comes down to the code that you've written to actually handle the job. And it also comes down to the actual hardware that you're running your application on, so the memory and the processing power. So all of those things combined are going to dictate how fast this queue actually gets run through, like how fast is everything resolved. So what we're doing is we're saying, okay, as that queue is being processed, you'll notice here I'm using Meteor bind environment. So I'm having to do this because inside of handle GitHub webhook, we're hitting one or multiple of our MongoDB collections. And so because those MongoDB collections are instantiated via the Meteor Mongo package, those collections need access, or they need Meteor in scope. And so the way that you do that when you have nested functions, so in this case handle GitHub webhook is being nested inside of a function that by default doesn't have access to the Meteor environment. And so what we're doing is we're binding that function, wrapping that code that's calling to the database, or to the Meteor instantiated Mongo collections. What we're doing is we're saying wrap that outer function in Meteor bind environment, which is essentially saying I'm going to pass that environment down to whatever function is wrapping that code. So that way when we execute that code, we're not going to get an error. So you've likely bumped into this if you've ever written code like this where you've nested some Meteor code inside of a parent function, and you get an error that says something in the effect of needs a running fiber to execute check bind environment, something like that. It's a really goofy error. But this is what it's getting at. It's basically saying, hey, I can't see Meteor, but I need Meteor to do my work. So using meteor bind environment, wrapping the outer parent function that's calling all of those functions that need meteor. That's how you do it. So inside of that function, we can see that that function is just a vanilla JavaScript function. There's nothing really special about it. So what I'm doing is I'm saying, okay, if job.data.service. So job.data is this entire object that we add to the webhooks queue. And so I'm saying if job.data.service equals GitHub, we want to handle GitHub webhook. Simple as that. And then all I do is just pass along the data. Not much to that part. So again, just as our queue is worked through, this is going to get called, this line is going to get called if the service we're getting it from is GitHub. So in the same way, because I will have to do this at some point coming up, I'm going to add a line like this. I'm going to say if it's Stripe, we'll say handle Stripe webhook with data job.data. Same exact pattern, just a different service and a different handler function. That's it. So I'm actually going to comment that out because I will need to use that at some point. So the very last part of this, and I'm trying to remember because I did it kind of on a whim, is we need to tell the queue that it's done with whatever that job is. So I forget the exact reason why, but you had to return a promise resolution from this function in order for it to do that. There's a good reason for that. I don't remember. If I do, I'll post it down in the show notes. Yeah, that's a read the documentation one. There is a good reason for that though. So let's dig into handle GitHub webhook. So again, this is the code that's going to actually decide what do we do with this webhook. And you'll want to remember that there's two paths. So if we go back, we have the ability to record a mention of a card on a card, and we also have the ability to close a card. So why don't we do that? Let's try and close this card. So this is number 47. So right now we've mentioned it, but we haven't closed it. We haven't done any actual interaction with this card. So back in our dummy repo, we're just going to say, woo! And we're going to save that. And back here, we're going to do a commit. So again, this is all driven by commit messages. So we're going to say closes number 47. Getting old, my memory's failing me. 47. Okay. So we're going to say closes 47. And we're going to push that. And we should see good. So ngrok got a message. Now, if we go back, what I haven't implemented yet in here is WebSockets or any real-time data. So even though we might expect something to pop up here, we're going to refresh to get to it. So if we refresh, okay, closed a few seconds ago, and there you are. So that's our two different variations of how this webhook is going to work. We're either going to record a mention, or we're going to actually be able to close it via commit message, which is pretty rad. So again, if I click on this, I'm going to see, oh, okay, this is what we did to say we're done with this or we're closing this issue out, which is pretty neat. So back in our code to get there, what we're going to do is all kinds of stuff. So this function, so here, you'll notice down here, this is what's being exported from this file. So this is literally this function right here. And what we're passing here is coming through as options. So you'll notice up here we've got validate options, which is a function that's just checking to see do we have the data that we need. So in this case I'm saying do we have options.data, options.data headers, and options.data body. And if all of those pass, that means that this code can run. If not, we just throw an error saying like, hey, something's wrong because you didn't pass us what you were supposed to. So once we get into that, then we get into the meat of this. And what we're going to do is start with this check if authenticated call. So what this function is going to help us do is to validate that the request we're getting is actually from GitHub. So if we take a look at that function, what we're doing is we're creating an HMAC digest, or basically the term you're going to think of as a hash. So we're creating a hash of the request body that we get from GitHub using this webhook secret. And you may remember this. So when we actually worked on updating the GitHub integration, what we did is when we created our hook, we passed the secret over to GitHub. So the secret is just like a long hexadecimal string, just a random string that GitHub can use to do the exact same thing we're doing here on their side. So what they do is, before they send us the webhook, they take the body along with our secret and they hash it, and then they store that hash inside of the headers as xhub signature. So this will come out as something like, it'll just be this long string of characters. What's neat about that is that that should equal the same exact thing on our side if we do the same process. So we're going to take the secret that we gave GitHub, but what we're going to do is we're going to hash the body that they sent us, or the webhook that they sent us. And so the output of that should match what we got from them if it's an authentic request. If it doesn't, then that immediately tells us, oh, okay, this either isn't from GitHub or something is wrong. And so that's it. So basically what we do is say, if the signatures do not match, just throw an error and stop the function. So don't even handle the GitHub webhook from here. We're just going to say stop, we're done. But if the request works and the signatures match, we're just going to return true and be done with it. So that's it. And again, we can see just the way this is called. So if this fails here, none of this code is going to execute. So we don't have to worry about anything else. So that's one. Two is trying to figure out, like, well, what type of webhook are we handling here? Now, what we've done is we've designed this to handle push and pull request events. So again, when we defined our webhook, or we added our webhook on GitHub, we said we want to watch for the events push and pull request. And so back here, we want to make sure that when a webhook comes in, that's what we're actually handling. The reason I did this is that when you first connect this, GitHub sends you just an identifying request that you don't really want to handle. It's just them saying like, hey, you're all set. We've got the repo set up. So what this is doing is preventing us from running any of this code if we get one of those. And we're going to get one of those every time a user connects. So we have to block that out from this chain of events. So if it is something that we actually care about, meaning a user has either push code with a commit message mentioning a card number or a pull request, what we're going to do is go to work and try to actually handle that request. So here what I'm doing is I'm just pulling data off of the request. So this isn't anything special. I'm using the lodash.get method to say, okay, from the options object, and again, options is the object that's passed in here. So this is equal to options here. So it comes in, and then eventually we get down to here, and we're trying to pick stuff off of it. So what I'm saying is, okay, from the data property of that options object, we want to try and get to body.repository.owner.id. And so what that's going to do, and this is part of the GitHub webhook data. So what this is going to do is it's going to tell us, okay, which user are we trying to associate this with? Because up until this point, we have no idea. Again, all webhooks are going to the same place, so we have to try and figure out, like, well, who does this belong to, or what are we doing with this? So part one is figuring out, well, who owns it, and then part two is which repository. And so we want to get the owner's user ID and the repo user ID. And then we're also trying to figure out which branch is this on. So again, remember that back in our config, we're allowing the user to tell us, oh, well, I only want to do this if the branch that the commit happened on is master in this case. So that's what I have it set to, or I could switch it to turkey. So in this case, we're going to leave it as master, but that's what that's doing. That's helping us to get the branch so that we can check whether or not we actually want to do this. And then the next step is trying to get the product. So the product is on our side. So again, we're managing products inside of command. So we want to get the product that's being referenced by that GitHub user ID. And so we're saying, okay, on that product, try and find that match. And then what we're going to do is say, from that product, we know that, oh, okay, this event is intended for this user, this product. And so that's probably going to evolve over time. It's kind of naive. So what I've done up until now is just assuming that you're going to connect one GitHub account to one product in command, but technically you could connect it to multiple. So eventually I'm going to have to come back and say, like, okay, I have to have some other identifying factor. But that'll come up later. So for now, that covers us. So back down here, what we're going to say is, okay, we've got the product, we've got all this information, and now the first thing we want to know is this a watched repo and branch? So do we even care about this event? Because again, we're going to get all pull and push and pull request events as webhooks from GitHub on this repo. So we got to check, do we care? So if we come into here, we're going to say, okay, from the integration in our database, get that. Again, pull the repo and the branch off of that. And what we're trying to do is we're saying, does the data in our database match the data that we got coming in from the webhook? So again, product is where we store the actual integration in our database, but then repository ID and branch from hook here, those are coming in from GitHub. So we're trying to compare and say, okay, is this the watched repository and is this the watched branch? And so that's all this check is doing. It's just telling us yes or no, do we care or do we not care? So back down below, if it is a watched repo and branch and hook configuration. So get hook configuration. There's a lot of this. We're pulling data out of a database. Most of this is just checking. We're just trying to see, are we allowed to do this? Because ultimately the actual handling of this is pretty simple. It's the build up to getting to that point that's difficult. So get hook configuration is checking, okay, based on the user's settings. So again, based on whatever they toggle for these two options, are we even allowed to do this? And so we just check in the database, what is the current value of that? So if they're both true, we're going to handle both of those types of events. And so back down here again, we're saying, okay, if we actually care about this repo and branch, and we're either allowed to sync commit mentions on cards or close via commit, that means we want to do something with this webhook. So let's keep going. And so now what we're doing is getting into the real crazy stuff. So the first thing we got to do is parse commits for activity and figure out, well, what's going on. So the commits are all of the commits that happen in relation to this webhook. So generally that could be just one commit. Hopefully it's one commit, but it could be multiple. So if you've ever, and I do this constantly, so if you do like 20 commits on your local machine and then you push, keep in mind, like in this case, that push event is taking all 20 of those commits in. So we need to figure out from all of those commits, what activity do we care about? So that's what this code is doing, is we're taking in the commits and we're mapping over each one and we're trying to figure out, okay, does it actually mention the card numbers or any card numbers? So, and I'm getting confused because I'm trying to remember how I did this. So we've got two different things. We've got the issue regex, and this is coming from, oh, that's not it. This is coming from a package. So I found this neat package, issue regex, that helps us to identify whether or not we're actually dealing with a mention inside of an issue. So we can see here, given some string, it's going to tell me which issue numbers are matched or which numbers are matched. And that same convention is used in command for cards. So I can get away with saying, okay, tell me which numbers or which repositories were mentioned inside of this commit message. So back over here, where do we go? So what I'm doing is I'm trying to see which numbers were mentioned. And then based on all of that information, I'm trying to figure out, okay, also, which closes were mentioned. Now, card mention regex is something that I wrote. So I've got all of these different keywords that I want to watch for. So if you say completes number 13 or improve number 13 or add number 13, any of those things come through, I want to catch it. And so that's what this regex is doing, is it's trying to say, can you find any of these patterns inside of the commit message? And so what we're trying to do here, and this was quite a doozy to work through. So what we're saying is closes mention numbers only. So this is just me parsing this data. So I'm just trying to get down to the point where I just have the numbers that are mentioned. And then closes mentioned as numbers. So what I'm doing is just building up a picture to figure out, okay, what was actually mentioned inside of this commit. So you'll notice I'm saying parse commits for activity. So what I'm not doing is trying to decide right here exactly that I want to close or anything like that. I'm just trying to figure out, okay, for this commit message, what was mentioned, both just in general as well as what was closed via commit. So that's all we're trying to do, is just figure out what came up. And then I'm also recording the ID of the commit message, so the first 7 digits of it. Typically that's used as a shorthand to say, like, okay, this is the commit, and we can point back to it without any trouble. So that's what we're trying to figure out. We're trying to say, okay, for this commit, what's its ID? Who was the author? What's the URL of the commit? So if we go back into command, the URL comes into play. Oh, right, we closed it. Where is it? 47. So the URL of the commit is what this is linking out to. So you'll notice this is a GitHub URL. This isn't an internal URL. So that URL is what's coming off of the commit here. And then again, we're combining the numbers mentioned and the closes mentioned all together. So we're mapping over this and then returning ourselves an array of objects detailing here's what this commit is actually about. So once we have our parse commits, then we're trying to get the activity from the commits. And this is equally tricky. So what we're doing is we're saying for each commit, we're trying to figure out, okay, which cards were mentioned in that commit. We're also trying to figure out which cards were closed in that commit. Now, this is where this gets a little freaky deaky. So if this is something you're curious about, you're not just learning in general, but you really want to know how to handle parsing commit messages from GitHub, you're going to want to slow down because this involves a lot of little details here. So what we're going to do is look at get cards and commits. So I'm taking in the ID of the product, and I'm also taking in that array of the numbers that were mentioned, potentially. So it could be an empty array, it may not be. So we want to get the numbers mentioned and the closes mentioned. So if we look at get cards and commit, what this is doing is it's trying to say, okay, from those card numbers, go and find in the product cards that match that commit number. So, or that number in the commit. This will twist your brain. So if we mention number 47, we expect 47 to be in this array, and we expect it to be with the product ID, MGKK, and the rest of that. So we're saying, okay, try and find the card with that number on that product. And then we want to get back the card ID. And so what that's allowing us to do is try and figure out, okay, well, which cards do we actually need to make changes to? And again, we only care about the card ID at that point. Because again, this is just a mention. We're not actually manipulating the card itself in any way. We're just saying, hey, what's the card ID? Because we're going to create activity independent of the card itself. And we'll see what I mean by that in a second. So we want to get all of the card IDs. And now once we have all of that, what we're doing is we're getting the activity. So we have the cards, so the card IDs, but then we need to build the activity that we're trying to insert. So when we look at get activity, what this is doing is it's saying, okay, give me the card that you found, so the card ID, and then we also need to insert all of the data about the activity. So this is literally describing one of these. So inside of command, I have a MongoDB collection called activity, where I store all of the activity items, completely independent of everything else. So when we do that, this is saying unpack or spread out the contents of card, which in this case is just the object right here. So basically we're just saying add card ID to this object. And then we're saying, okay, we also need to set a topic. So in this case, the topic is if the activity equals mentioned, we're just saying the event is GitHub. Otherwise, it's closed card. So we'll see in a little bit when we look at how the activity collection works. I'm looking or filtering for different types of activity, and that's an internal thing. So you'll notice here, this gets the GitHub logo. This one gets the red circle with an X through it. That's the type driving that. So this is type GitHub. This is type, what do I call it, closed card. And then we have the actual activity. So here what I'm doing is my activity collection expects that the activity field on an object in the database can store HTML. So I'm building the actual HTML that's being rendered here. So we can see, okay, username in bold, close this card and commit, link to the commit ID on GitHub in bold. And so what we're doing is we're actually building out that HTML here. So we're saying, okay, we want to embed the URL from the commit. We want to embed the ID from the commit. And again, commit ID here is the shorthand version that we pulled off right here. So that was us saying, only give us the first 7 digits because the commit ID is pretty long. I forget what it exactly is, but only grab those first 7 digits. So that's us actually building what's showing up back here in the UI. So pretty cool. And then once we have that, we also have the author. So again, the author is driven by when we render the actual activity on the card. So you'll notice I'm not embedding Clever Beagle, mention this card, or Clever Beagle, anything like that. I'm putting the name separate, and that's because the UI that renders that out to screen, manages all that for us. And then the final part is we need to know when it happens. So we're saying, okay, here's the created at date for the activity. So with all of that, now we have all of the activity that we need to put into the database. So that's all of the hard work done. And you'll notice here, before I return this, what I'm doing is I'm using lodash.flatten. And the reason why is that what the end result of this is all going to be is we're going to have a bunch of nested arrays. And so I need to flatten those arrays down to one array. We don't want it to be, having to loop through all these nested arrays. That would be not fun. So what we do is we get that back. And then once we have all the activity from our commits, then it becomes a little bit easier. So now we say insert activity. And insert activity is doing this. So we're saying in the hook configuration, again, we may or may not be allowed to actually do what we're trying to do. So we have to check again. So we're saying if the hook configuration says that we're allowed to sync commit mentions on cards, for each one of those mentions, we want to insert into the activity collection. So if this was false, this would never run. We don't want to do it unless the user has told us that we're allowed to do it. So that's one. And then two is the exact same thing, but for allow close via commit. So we only want to insert this into the database if we're actually allowed to do it. And so we have to do this check again because remember, either or might be true. So the either or of either of those settings might be true here. So what we have to do is say like, okay, if either of those is true, we got to double check again which one is true. And so that's what that code is doing. And so that's us logging the activity. So activity is just it's kind of like a notification. So we're just saying like, hey, this happened. But that's it. It's not doing anything. There's no actual interaction there. It's just saying, here's some information about what took place. Where it actually gets interesting in terms of interactivity is back here. So we've got, okay, our activity is in the database, but then we're saying close cards from activity. So we're trying to tell ourselves, okay, can we actually close stuff via commit? And then we're also trying to say, well, what was the activity? Like, what are the activity items that are trying to close stuff? So if we look at that, what we're doing is we're saying, okay, for each piece of activity, so if we're allowed to close via commit, only if we're allowed to close via commit, what we're trying to do is say, okay, for each piece of activity, grab the card ID, and then we're going to set that card open to false along with a closed at timestamp. So when we did this, and it's still closed, so closing it is basically you flag it as open false in the database, and then in the UI that shows it crossed out, and it also sets the closed timestamp here. So that's part two. So part one is logging the event that we closed it, but then part two is actually closing it in the database. And so because we could have multiple cards that get mentioned, we want to loop through all of them and actually do the close on that card. Whew. So that is it. That is handling the GitHub webhook. So that is, like I said, when we started this, it was pretty wild. A lot of steps involved, a lot of thinking involved. So the thing I learned from doing this, because I've worked with GitHub webhooks before, but not to this level of detail. And the thing I found is just take your time. It's real. I actually rushed through an implementation of this the first time and screwed it up, so I had to go back and redo it. So the best thing I could say is take your time with this stuff and be patient, because you're dealing with data that isn't from you, and so you have to get really comfortable with dealing with like nitpicky details. And GitHub, fortunately this isn't the case, but with a lot of these things sometimes you'll get bad documentation and things like that, and it can frustrate the hell out of you and kind of force you to make compromises that you shouldn't. So no matter what, take your time with this stuff and be patient, because once you get it right, it's right, and you don't have to come back and fix it. And it's honestly, just from a geek standpoint, this is super cool when activity on a third-party service that you don't control can do stuff inside of your application. And granted, this is a simple version of that, but over time I can expand this now and trust that it's going to work without a lot of fear or concern about it failing, which is great. So with that, I am going to head out. As always, if you haven't already, click the button down below to subscribe and hit the bell just next to it if you want to get notifications as soon as these are live. And as always, if you have any questions, post them down below in the comments. So with that, signing off for the HMS Beagle. I'll see you next week, folks. This is handled in a lot of different ways for different services. This is how GitHub has you do it. I know that Stripe, when they do it, they give you an actual part of their ooh, there's a bee outside my window and I thought it was inside. You just listened to me run my mouth for the better part of an hour about a bunch of really technical code. So why not commemorate that experience by watching another tutorial and having an absolute psychological meltdown?